CCEA Factfile 4.8 A2 Chemistry Carboxylic Acids Factfile. And these are the answers. So question 1. Which one of the following compounds reacts with propanoic acid to form propanoyl chloride? Dead easy. Phosphorus pentachloride. Shouldn't have to think about that one. Lauric acid then, question 2. C11H23COOH. The main acid found in coconut oil is also found in macadamia nuts. It's a white solid at room temperature with a melting point of 45 degrees and is insoluble in water. Write the empirical formula for lauric acid. So if we look at this, you see there are 11 carbons and another one is 12, and then 23 and one is 24, and then we have 2 oxygens. So the molecular formula is C12H24O2. Now, because those are all even numbers, we can divide by 2. That gives us the empirical formula, or the simplest ratio for the elements in the compound, which is C6H12O. Now, then we have to explain why ethanoic acid is soluble in water, whereas lauric acid is insoluble. So the main marking points in this are the fact that your ethanoic acid can form hydrogen bonds with the water, and those bonds are then between the hydrogen of the H2O and the oxygen in the carboxylic acid group. Now, lauric acid, because it has a longer chain and it's 12 carbons long, that chain becomes very hydrophobic. So the hydrophobic chain means it's insoluble. Describe a chemical test to prove that lauric acid is an acid. Well, your test for any acid is to add carbonate. And you add that just to the liquid lauric acid. And what you'll see is fizzing, or you could talk about the test for carbon dioxide, which of course is you bubble it through lime water and the lime water goes cloudy or milky. D, write an equation for the reaction of lauric acid with phosphorus pentachloride. So any acid in PCl5 is going to give you the substitution of that OH group for a Cl, and then you get POCl3 and HCl are your other products. Then it can be reduced to the corresponding alcohol. Write an equation for the reduction using H in square brackets to represent the reducing agent. So there's our lauric acid and our H's, and we actually need 4 of them to balance the equation, and then we end up with the alcohol there and water as the other product. And then name a suitable reducing agent. Well, it's lethal. Just be careful. Don't write the formula there. You can give the longer name for lethal if you want, but lethal will be perfectly fine. It's acceptable. Right. Last page. Write the equations for the reactions of propanoic acid and magnesium. So any acid and magnesium are going to give you the salt and hydrogen. And then with methanoic acid and sodium carbonate, so methanoic acid just HCOOH, sodium carbonate Na2CO3, and we're getting the sodium salt, which is HCOONA. We need 2 of those because there's 2 sodiums in the sodium carbonate, and the other products then, a carbonate and an acid will always give you a salt, plus water plus carbon dioxide. And then butanoic acid with potassium hydroxide this time. So there's our butanoic acid, CH3, CH2, CH3, COOH, and then potassium hydroxide, KOH, and we get the potassium salt here and water. And finally, we've got this little reaction scheme. So pyruvic acid shows reactions of both a ketone and a carboxylic acid. So here's, when we draw it out here, there's pyruvic acid, CH3COCOOH. And you look here, there's the ketone group, and then here is the acid group. So it says complete the following flow sequences below showing the organic product in each case. So the first one with PCl5, so that's going to react with the acid group here, and that means we're substituting this OH group for this Cl. So there's your product there. Okay, so the OH and the acid group has been changed for a Cl. So if we look at the middle reaction next with lethal, so in this case it's going to attack both of the carbonyl groups, and we're going to end up with both of those being reduced to give us alcohol. So we end up then with a triol there with 3 of the OH groups on it. In this one, that's the 240 mph, So we're getting this compound then. It's just a matter of making sure you learn this and how you connect it. And you see that it's joining on to, let me just change my colour to this one. Okay. And then finally we have the HCN, and it's just adding on to that middle carbon here. Okay. All done. Thank you for watching.